Hi everyone, welcome to PrepFusion. So this is the part 3 of our transmission line. We have already seen part 1 and part 2. So what kind of series we are running? We are running the series for GATE 125 students. Even if you haven't studied your transmission line at all, even if you don't know a single thing about transmission line or a single thing about EMFT, still you will be able to understand these three particular videos, and there is very high chance that from these videos only the final examination questions will come. Okay, so there is very high chance I am expecting that from these from these three topics, 4 marks of question can come from EMFT in the final examination, because in EMFT the most important topic is transmission line, and in the transmission line the most important topics are these three. First one we saw impedances, second we saw standing wave pattern, and third we are going to see the equivalent circuit of transmission line. Okay, so just hold on till the end of the video, you will understand every single thing. And yeah, one more thing, like before watching this video you need to watch those previous two videos that you will find on the channel itself, or today I will try to make a playlist as well, so in that playlist you can find it out. I will give the name of the playlist as Gate 2025 one shot. This name I can give. Okay, Gate 125 one shot. So there you will find those two video about EMFT. We are also running for control system as well. We are also running for analog electronics as well, right? So yeah, let's get started with our topic now. We need to see the equivalent circuit of transmission line. So what we have seen on transmission line, what did we show? That sir, this kind of wire would be there, two wire would be there, and both are conductors. This is also conductor, and this is also conductor. And in between there will be a dielectric. In between the wires, there will be a dielectric having epsilon r constant, dielectric constant of epsilon r, right? At the load I can connect any load, or I can keep it open as well. Like load could be open circuit, short circuit, or a random ZL. Here I could have connected a random ZL. The value of ZL could be anything: inductive, complex inductive, capacitive, complex capacitive, resistive, open circuit, short circuit. It could be anything, right? Now answer me one thing. Let's just say if here you are having open circuit load, the line is open circuit, and now if I close the switch, if I close this switch, so will there be any current through the transmission line? Just answer me this question. Or before that, answer me this question. Let's just say this is a question of network analysis. That there is a wire, and I connect a battery here. Okay, and I ask you, what is the current through this wire? What you will say? Sir, it is open circuit. There will be 0 ampere current. Why did you say so? Because in the network theory, whatever the impedance that you see from here, the same impedance you will see from here as well. Say yes or no? So always you will see open circuit impedance. The resistance is infinity, so there will be no current. But in case of transmission line, if you see the first video, here you will see Z equals to infinity. But once you walk across the transmission line, just as you start walking across the transmission line, the impedance will start changing. At every single point, the impedance will change. Even if you cover the distance of 0.0000001 L, still the impedance will change. So at every point, impedance will keep on changing. You will get two kind of resistive element as well that we have seen in the standing wave pattern. So in that manner, resistance will keep on changing. So only at the load there is infinity impedance. That means in the load there will be no current, but certainly in the transmission line there will be current, because at this particular point the impedance will be different. At this particular point the impedance will be different, right? So if there is some impedance, that means it is a closed path, and if it is a closed path, that means there will be current. So if I say a statement that if my transmission line is having a load of ZL equals to infinity, and I apply a voltage source at the input, will I get any current? Yes, you will get the current, even if it is open circuited. Okay, so that was the point I wanted to tell. So even if I keep, here this was conductor. Okay, yeah. So what I was saying, even if I keep it open circuited, and just as I close the switch, then what will happen? What did I say? That a voltage wave is generated. Voltage wave is generated, and a current wave is also generated. You don't need to remember this V0 plus or I0 plus. And then what happens? They get reflected back, and then we get the concept of a reflection coefficient. That also we saw that with respect to the complete transmission line, reflection coefficient also changes. And since there is forward wave, there is backward wave, both combined will make the standing wave pattern. So this also we have seen. So the bottom line is that there will be current. Now just let me know one thing. If in a wire there is a current, that means wire will certainly have some resistance, no? Conductor will certainly have some resistance, unless the conductor is ideal. Let's just say in network theory I am solving this question, that this is my wire, there was a resistance, that was this R resistance was there, then I connected this R resistance through a wire to a battery. This was my battery, so I connected this R resistance through a wire to a battery. So in network theory, what do I say? That this wire will have zero resistance, and the current, just as I close the switch, the current in the resistor will be V by R. But here, this if there is some current flowing, that means there will be some resistance as well. So your conducting wire will have some resistance. Your conducting wire will have some resistance. Now in the inductor, if the current is flowing, so if you remember your higher secondary classes, if the current is flowing, then there will be flux linkage. If there is current, that means there will be magnetic field, right? In a wire, if the current is flowing in this manner, then right hand rule, there will be magnetic field, and if there is magnetic field, there will be flux linkage. If there is B, then there will be phi, and if there is phi equals to Li, that means there will be inductance as well. So basically you can just remember one thing, that if there is current, that means there will be resistance, and if there is resistance, that means certainly with resistance there will be inductor as well, there will be inductance as well. Okay, no one will ask you the reason behind that, just you need to know that how I am replacing my transmission line with the simple RLC circuit. Okay, now let's just say this is one plate, this is another plate. If there is some current flowing in the plate, so I am assuming that here positive charge is coming, here negative charge is coming. What I am saying, that here positive charge is coming, and let's just say here negative charge is coming. Positive charge, negative charge, in between there is a dielectric. What it will give? Capacitance, right? Two plates, in between there is a dielectric, here positive charge, here negative charge. So what it will result in? Capacitance, right? So there will be one capacitance as well. But capacitance, how will you show the capacitance? This is how you will show the capacitance. No, capacitance is there between these two, no? So I will show the capacitance in parallel, right? I will show the capacitance in parallel. So this is how I am going to show the capacitance. Okay. Now there is a dielectric. This is a dielectric, right? If there was loss in the conductor, that means there was resistance. Look, if you flow some current in the conductor, then there will be some loss, there will be power loss. The conductor will be heating up, right? The conductor will be heating up. So there will be loss. So that power loss is shown by this resistance. Now there is this dielectric as well, no? This dielectric can also be lossy. What do I mean? That let's just say, just I close the switch, this V0 plus was generated. So here V0 plus was generated. Now it will be a traveling wave. Do you remember the graph of traveling wave? So wave will travel. So this was our graph of traveling wave. But what may happen is that just as the wave starts traveling, it may keep on losing its amplitude. The wave is traveling in this medium. Now this medium could be lossy. And if it is a lossy medium, that means the wave will lose its amplitude. Usually they lose the amplitude exponentially. So wave may lose its amplitude exponentially. So if the medium is lossy, then that lossy element also I need to show. So lossy element, how do we show? By resistance. But since it is coming in between, so I will show it by not transconductance, I will show it by conductance. So this is your G. So this R and G both are complete different thing. This R is coming because of the conductor, and this G is coming because of the dielectric. Okay, this is associated with the dielectric, and this is associated with the conductor. Okay, and what is this G? G is shown by resistance, but it is not actually resistance. It is 1 upon resistance. Basically, this have a unit of Maho. This is what I mean to say, and this have a unit of Ohm. But since it is coming because of the dielectric, that's why I am showing it in parallel. So this is how you show your transmission line. Okay. Now I will use a term that is known as distributive element and lumped element. What do I mean by that? We have studied it in network analysis, but let's just again recall it. So let's just say this is a simple network circuit you are having. This is a simple circuit you are having. Now I tell you that bro, go and get 1 Henry inductance out of the circuit. What I am saying, go and remove the 1 Henry inductance out of the circuit. So what you will do, you will just remove this. If I say go and remove 2 ohm resistance out of the circuit, then you will just remove it, because in the circuit you can directly see there is 2 ohm, there is 1 Henry. But in the transmission line I can see wires. The R, L, G, C are inbuilt there. They are coming because of the current, because of the dielectric, because of the lossy nature. They are inbuilt there. So they are distributive along the transmission line. Along the complete transmission line, this R, L, G, C are distributed. So they are always defined with respect to per length. Okay. So here the unit will not be ohm, it will be ohm per meter. Here it will be mho per meter. What do I mean by that per length? They will say that the length of transmission line is, let's just say, 2 centimeter. Okay. And the resistance of the transmission line is 0.2 ohm per centimeter. That means on the complete transmission line, for 1 centimeter there is 2 ohm, 0.2 ohm resistance. So for 2 centimeter there will be 0.4 ohm resistance. So on the complete transmission line there is 0.4 ohm resistance. Same goes for inductance as well. Same goes for conductance as well, and same goes for capacitance as well. Let's take the example of capacitance. So what they can say, there is 3 microfarad capacitance per centimeter on the transmission line, and the length of transmission line is 3 centimeter. That means 9 microfarad capacitance is distributed along the complete transmission line. Are you getting this point? Okay. So they are always defined with respect to per centimeter or per meter or per unit length. Is that okay for you? So now this equivalent circuit that I have made, that I will make with respect to some small length. What I am gonna do is that on the transmission line I am gonna take a small length, that is delta Z. On the complete length L, I am gonna take a small length, that is delta Z. Now my R will be having a unit of ohm per meter, or meter, or it could be anything, centimeter also it could be, right? So what should I write? I am writing SI unit, so ohm per meter I am writing. Okay. L would be Henry per meter, C would be farad per meter, and G would be Siemens per meter or mho per meter. Siemens per meter or mho per meter. Mho and Siemens both are same thing. Okay. So that means per unit length this much resistance is there, R resistance is there. Per unit length R resistance is there. That means in delta Z length, how much resistance would be there? R into delta Z, right? So this I can write as R into delta Z. I am just taking a small portion of delta Z. So there R into delta Z total resistance would be there. L into delta Z total resistance would be there. C into delta Z total capacitance would be there. This was actually inductance, not resistance, sorry. This was inductance. So total L into delta Z inductance would be there, and total G into delta Z conductance would be there. Say yes or no. So that's why it is shown as R into delta Z. What do you mean by R into delta Z? That means R is the total resistance per unit length, and into delta Z, that means you are taking a small portion of delta Z where you see this RLGC. If I take another, let's just say I can take another delta Y portion. I can take on the transmission line only, I can take another delta Y portion. So there what I will see? R into delta Y, L into delta Y, C into delta Y, and G into delta Y. Is that clear to you? Is this slide clear to you? So basically in this, what is the conclusion now? So in this transmission line you will see R, L, G, C. Why R is coming? Because of the current in the conductor. Okay. Why L is coming? If there is current, there will be magnetic field and there will be flux linkage. And if there is flux linkage, that means L will come into action. Why C is coming? Positive charge, negative charge, in between there is an electric. That means C would come. Why G is coming? Because of the loss. Because V0 plus I0 plus that is generated. If that travels through the medium, that dielectric medium that you are having, that can have some loss. So because of that loss, G is coming. So one thing I'm gonna write down here, that this R and G are not related to each other. There is no relation between R and G. Is that okay for you? Because this R is because of the conductor and G is because of the dielectric. Is that okay for you? Say yes or no. Right? So on this slide, we can keep all these things. Now we will see a question in GATE 123, which was solved by everyone wrong. You can go and check the solutions of gate 123. It was solved wrong by everyone. What is the reason behind that? Okay. So equivalent circuit of a transmission line you need to tell, and it was a MSQ. So how will I draw the equivalent circuit? So first let me draw a transmission line. So what is the way that there is a transmission line which is of length L, but what I'm going to do is that on the transmission line I'm going to take a small length that is delta Z. Okay. Now in this small length, what do I get? R into delta Z, L into delta Z, C into delta Z, and G into delta Z. Now next as well, what I can do here is that I can take another some different length. No, here I can take some another different length that would be delta Y. So here what I will get? Again I will get R into delta Y. Then what I will get? Again I will get L into delta Y. Then C into delta Y and G into delta Y. Right? C into delta Y and G into delta Y. Now how you can get this particular option? First option, let's see the first one. Okay, let's see the first. Let's forget about the first one. First let's see which option is matching with us. So option D is matching with us, right? That's our RLGC. Then again LR is there, so RLGC in that manner we can have, right? So you would mark option D correct. So luckily you are correct here. The point is what you can see here, what they are saying, R by 2 delta Z. Here what they are saying, L by 2 delta Z. Here what they are saying, L by 2 delta Z. And what they are saying, R by 2 delta Z. So what they have taken delta Z only, but they have divided R into R by 2 R by 2. Are you getting this point? And L into L by 2 L by 2. Basically the point is delta, I am saying that I am taking my delta Z in this manner. In this manner. This is the delta Z I am taking. But what he is saying that I am taking my delta Z in this manner. So basically there, this is delta Z, this is the delta Z portion, but here I am taking half of resistance only. The point is he is taking, like, this is your delta Z. So what he is doing is that he is taking half part of delta Z and half part of delta Y. This is what he is doing. Basically, he will take a small portion of delta Z or delta Y on the transmission line, right? It is not necessary that they will take the complete this portion, or it is not necessary that they will take complete this portion. What they are saying is that I am taking half portion of delta Z and half portion of delta Y, and then I am giving this as the name of delta Z. So in half portion, what is happening is that this is coming complete, but from here R by 2 is coming, from here L by 2 is coming, from here R by 2 is coming, from here L by 2 is coming. So R by 2 delta Z, L by 2 delta Z, L by 2 delta Z, R by 2 delta Z. So that's why this option was correct. So what is the bottom line? The conclusion is you can take the area, like you can take the small length anywhere, but in the small length there should be one R into delta Z, like one complete R into delta Z, because here R by 2, here R by 2. There should be one complete L into delta Z, there should be one complete G into delta Z, and there should be one complete C into delta Z. Basically you should get them to be 1 1 1 1. So there is R by 2 complete one R is there, L by 2 complete one L is there, G by 2 C by 2 complete one G, sorry, not G by 2, sorry, it is complete one G, it is complete one C. That's why this option D is correct. It is MSQ. Let's check more options now. What about this one? So here how they have chosen? They have chosen the length to be something like this, right? So here what you can see, half C by 2, half C by 2. Both will come into parallel. It will make one C. G by 2, it will make one G. One R is there, one L is there. This is also correct. What about this one? And sir, how will you get this one? Our RLGC was this only, no? No. They have taken RLGC to be something like this, and then they gave this as delta Z. So one C, one G, one R, one L. GC both in parallel, RL both in series. So 1 1 1 1. So this is also correct. Why this is wrong? How you can get this thing first? Look, this is correct. Just 1 second. Yeah, this was correct. How you can get this particular circuitry? C, RL and G. This is how you can get it. C, RL and G. This is how I can get it. Look, C is there, RL is there and G is there. But what is the catch here? Complete G should be there, complete C should be there, complete R should be there and complete L should be there. L is 1, R is 1, G is G by 2 and C is C by 2. That's why this is wrong. Are you able to understand the point now? So what you are going to do in the examination, you will make complete RLGC. Okay, you will complete make RLGC. Then you can see that, sir, if I take this portion, then I can get this particular circuitry. If I take this portion, then I can get this particular circuitry, sir. If I take this much of portion, then sir I can get third option and then fourth option also I can get. But the thing is, in the complete delta Z length, basically this is your complete delta Z length. This is also your complete delta Z length. So in the complete delta Z length, I should get 1 R, 1 L, 1 C and 1 G. That's it. And this is how I will match the options. This was asked in GATE 2023. And surprisingly, the same kind of questions was asked in 2015 as well. But no one noticed it and they gave it wrong. Still, you can see the textbook as well. The explanation is not given correctly. Answer was given BCD. And even in the solution as well, still the answer was given like some are saying ABC would be correct, some are saying ABCD whole would be correct. BCD would be correct and region also you know now. Okay, the region also you understand. The same question was asked in 2015 as well. But there it was not MSQ. So luckily we got it correct. What they asked? They said that this is a conductor. In between the material that you are using, that is Teflon. The material that you are using, that is Teflon. And the Teflon is having tan loss equals to 0. Okay, loss tangent is 0. So those who have studied EM wave, then they would know what do they mean by this. Loss tangent is 0. So if in the examination you see this kind of expression, tan neta is equals to 0. So what does that mean? You will say that there is no loss. What does this mean? No loss. In the examination, if you see tan neta is equals to 0, that means there is no loss. If there is no loss, that means this Teflon is having no loss. What does that mean? That if here V0 plus was generated, then this V0 plus will not lose its amplitude. It will just keep on traveling with V0 plus only. I0 plus is generated. So this I0 plus will not lose its amplitude. It will travel with I0 plus only. So this is the meaning of no loss. Okay. So if there is no loss, then let me know which value will be 0. R will be 0, L will be 0, G will be infinity or G will be 0, C will be 0, C will be infinity. Just let me know this thing. If there is no loss, what does that mean? That your G would be infinity. That means G would not come into action. What is our equivalent circuit? This is our equivalent circuit. R, L, G and C. Right? How this R is coming into action? Because of the conductor. They did not say anything about the conductor. That means you will consider the loss. That means there will be R. Why this L is coming into action? L is coming into action because of a magnetic field, flux linkage. That's why there is L. So you will take this also into action. Why this C is coming into action? Is there any role of loss? For defining C, is there any role of loss? What do I mean? That there is this conducting plate, there is another conducting plate. Even if there is air or even if there is water, even if there is any medium which is lossy or lossless, still there will be capacitance. Because the necessary condition for the capacitance is there should be two plates which are far apart by a certain distance and there could be any material. Whether it could be lossy or lossless, capacitance don't care about that. So, what was this? This was coming because of the loss. This G was coming because of the loss. So now if loss is not there, that means G is not there. So that means this G should be removed. And in parallel, if you remove a impedance, in parallel, if I am removing a resistance, what does that mean? That this should be infinite. Sorry, this should be infinity. Yeah. this should be infinity. So I said that G should be infinity, that is, I'm sorry for that, G should be 0. If G is 0, that means this resistance would be infinity, and if there is a resistance that is infinity, that means it will be open circuited. Basically G was what? G was mho. So if 0 mho means infinity ohm, 0 mho means infinity ohm, right? So infinity ohm means open circuit. Open circuit means G would be gone. Open circuit means G would be gone. So there will be one R, there will be one L, and there will be one C. Luckily, there was only one option where there was no G. There was only one option where there was no G. In all the options, G was present. So all other options were wrong and this was correct. But now if they ask this kind of problem, then they will frame these options, because now they can ask MSQ. So they will frame these options. What they will do, they will just remove this G. Rest all will remain as it is. They will just remove this G. They will just remove it. Rest all remains as it is. So all three options are correct. B, C, D. Are you getting this point? And how this could be correct? They remove this G, and in place of C by 2, they write down C into delta Z. So this is also correct then. So now what is the point of this 25-minute discussion? Why R is coming, why L is coming, why G is coming, why C is coming, you should be knowing about that, right? If you are knowing about that, then it is pretty good. You will be able to solve the problems. Okay. And what if they say conductor is ideal? What if they say that conductor is ideal? Ideal conductor means they will say that the sigma here is infinity. Why I am introducing all these terms? Because like you would be getting confused. This video is mainly for those guys who are studying it for the first time. They wouldn't even know what is sigma. Sigma is actually conductivity. In network analysis, you would have studied J equals to sigma E. So that sigma I am writing down here. If sigma is conductivity, if sigma is infinity, that means this R will be 0. So they can write down in the examination that it is an ideal conductor. Or what is the other term? Ideal conductor, or what do we call it? Perfect conductor. Okay, ideal conductor, or they can say perfect conductor. Perfect conductor means sigma is equals to infinity. And if sigma is equals to infinity, that means this R will be 0. So there will be no loss. So the equivalent circuit will only be LC. LC, 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 LC. Okay. So this also they can ask, but they have asked about lossless material, Teflon. They said that Teflon is lossless. I guess in the examination, in the language as well, it was written that it is lossless. Lossless means there is no loss. And if there is no loss, that means G will not come into action. So why RLGC are coming? How do we represent it? I hope all these things are clear. Okay. All these are very, very clear. So if this kind of question is coming in the examination, then you would be able to solve it. Now, based on the material that you are using, based on the material that you are using here, based on that, you can define your transmission line into three kind of parts: distortionless, lossless, and lossy transmission line. And in lossy, they will only ask the case of low loss. So all these things you don't need to remember. Here I am just gonna tell you a problem solving technique. Those who have studied it comprehensively, they would know what is the meaning of lossless. They would know. Now you also know what is the meaning of lossless, right? What is the meaning of lossless? Lossless means there will be no loss in the V0 plus amplitude. V0 plus will be same. I0 plus will be same. Now you might not be knowing the meaning of distortionless. Distortion means basically if this is my V0 plus waveform, okay, so always it should be like this only. Basically this transition should be smooth. I should get this kind of waveform. It's not like that first the transition is like this, then transition is like this, then transition is this. Here again the amplitude remains same. Amplitude remains same, but still this width is changing, no? So that I don't want. So that is known as distortionless. And what is lossy? Lossy means the amplitude will keep on decaying. Lossy means G is present. So here we started with V0 plus, then amplitude will keep on decaying. Okay. So these are the three kind of medium could be there. Three kind of medium could be there. Okay for you. But you don't need to keep stress on this part. We will just develop three formula here, and based on that three formula, at least 10 PYQs you would be able to solve from transmission line. On those formula only 10 PYQs are asked. On those three formula. So this is very, very important. Okay. So let's get started. So in the examination, any line could be written. You don't even need to think about it. They can write down, sir, it is distortionless line. They can write down, it could be lossy line. They will just write down lossy line it is. If they are asking any question on lossy lines, that means 100% it will be on the low loss case. 100% I am saying 100%, because if they want to frame a numerical, it has to be low loss case. Okay, so they will just say in the examination, what they will say, they will just say that the line is lossy. So in the mind you would know that, okay, whatever that I have studied, based on that I can solve the problem. They can say that line is distortionless, they can say that line is lossless. So if this is the condition, if these are the lines that are given, then there is one condition. What is that? That R by L would be equals to, okay, not R by L, we will write down L by R. L by R would be equals to C by G. I will tell you a way to remember this thing, okay? A very simple way I will tell you. So the thing is, if in the examination any kind of transmission line is given, for any kind of transmission line you can apply this particular relation, that L by R is equals to C by G. How will you remember? For RL circuit, what is the time constant? For RL circuit, what is the time constant? L by R. How do you remember it? How do I write time constant? This is how I write time constant. How do I write L? This is how I write L. Both look similar, right? Tau and L both look similar. So it would be L by R. It would not be R by L. Basically, the confusion would be, sir, okay, sir, what is the time constant? L by R or R by L? So what you will do? Okay, tau. Tau looks like this and L looks like this. So that means tau and L should be in front of each other. So tau is equals to L by R. Okay, so this is how I remember. So what is the time constant for LR circuit? That is L by R. L by R should be equals to the time constant of RC circuit. What is the time constant of RC circuit? That is R into C. So R into C, but here in place of R, what is there? G. So divided by G, because G is Maho. Basically, time constant is Farad into Ohm. But here what is the scene? L by R, which is Henry upon Ohm. There is no issue with that. But here what will be the scene? C by G would be coming. Why C by G would be coming? Because with C, what do you get? G you get. And G is 1 by Ohm. So if you need 1 by Ohm, so C by G you need to do. So L by R is equals to C by G. It is not tough to remember. Will you be able to remember in the examination? That any kind of transmission line is given, they will ask you attenuation constant, phase constant, propagation constant and characteristic impedance. Before that, we can apply this condition, that our L by R is equals to C by G. Say yes or no. From here we can get other relation, like basically if you solve this thing, what do you get? LG equals to CR, LGTV or LGBTQ. This word also you can remember, or LGTV you can remember, is equals to CR, class representative, or you can remember LGBTQ is equals to class representative. In that way you can remember LG is equals to CR. Just I am telling you a way, okay? Just I am telling you certain ways. So LGTV is equals to CR. In that manner you can remember, okay? So LG is equals to CR. Or from here what do you get? R by L is equals to G by C. R by L is equals to G by C. This is also a way to remember. R by L is equals to G by C. Not a way to remember, just I inverted it. So these things you can get from this particular expression. So any way you need to remember that if transmission line is given, then my LG would be equals to CR, or R by L is equals to G by C, or L by R is equals to C by G. The best way is the time constant thing. This is how I remember. Time constant L by R is equals to RC C by G. That's it. Okay. Now, there is one certain thing for lossless transmission line. If they are saying the transmission line is lossless, what do they mean? That conductor is also lossless and the material that you are using, that is also lossless. If they are saying the transmission line is lossless, what do they mean by that? The conductor that you are using, this is also lossless and this thing is also lossless. What does that mean? That your R should be equals to G should be equals to 0. Say yes or no. For lossless transmission line, R should be equals to G should be equals to 0. Say yes or no. Why it should be equals to 0? Because if R is 0, that means there is no loss in the conductor, only L will be into action. And if G is 0, that means here resistance would be infinity. And if resistance is infinity, that means it will be open circuited. So here it will be replaced with only C. So LC. So LC circuit you will get. LC. In that manner you will get. If the line is lossless. And they are saying lossless line, that means they are talking about the medium as well and they are talking about the conductor as well. So R and G both are equal to 0. Now if R and G both are equal to 0, So do we satisfy this condition? R by L is equals to G by C. Yes. R 0 by L, G 0 by C. 0 equals to 0. So it is not necessary that always R and G would be equals to 0. It is not necessary. It is necessary only for the lossless line. So what is the conclusion till now? That any line would be given in the examination. What we will do? That sir, L by R is equals to C by G. This is the first thing I will do. Second, I will check that if it is mentioned lossless, and if it is mentioned lossless, that means I would know that R equals to G equals to 0. If lossless is not mentioned, then this is the condition I am having. If lossless is mentioned, then R equals to G equals to 0. We will solve the problem. It will become very easy for you. Then they can ask these formula. What they can ask? Attenuation constant. So what is the value of attenuation constant? Alpha. Attenuation constant is shown by alpha. So alpha is equals to under root Rahul Gandhi. Okay. Under root RG. Alpha is equals to under root RG. Attenuation constant. Basically, here what was generated? V naught plus was generated. So now if it travels a distance, let's just say it travels a distance. So how your V naught plus will be reducing? E to the power minus alpha z. This is how your V naught plus will be reducing. Exponentially it will be reducing. The magnitude, the peak value, that was V naught plus. Peak value was V naught plus. But if it keeps on traveling with respect to the distance, it will keep on decreasing its amplitude. So e to the power minus alpha z. This is how it will keep on decreasing its amplitude. If what will be the formula for that? Alpha equals to under root RG. If the line is lossless, that means whatever the V naught plus was generated, the same V naught plus will keep on traveling. Say yes or no. If the line is lossless, whatever the V naught plus was generated, the same V naught plus will keep on traveling if the line is lossless. That means alpha should be 0. And are we getting the same thing? For lossless line, what is the condition? R equals to G equals to 0. If I put 0 into 0, under root 0, that would be 0 only. So for lossless transmission line, alpha is also equals to 0. So R equals to G equals to 0 is equals to alpha. So for lossless transmission line, attenuation constant is 0. But what you will remember? You will remember only this thing, that formula of attenuation constant is equals to under root Rahul Gandhi. Okay. Let's write down the formula of characteristics impedance, because this is more important. Characteristics impedance, that is Z0. So that I told you that for every transmission line there is some characteristic impedance Z0. So that also depends on this RLDC parameter. So that formula you will write down as under root L by C. Under root L by C. So that is the second formula. Now someone like will say that sir, in the examination I can get confused. It is under root C by L or under root L by C. So you will not get confused. Why so? Because when you write down the impedance provided by the inductor, how do you write down? XL equals to J omega L. And for capacitor, what do we write? 1 by J omega C. So L will always come in the numerator and C will always come in the denominator. So Z0 equals to under root L by C. So this thing you would have noticed if you have studied from PrepFusion, that whenever I ask anyone to remember any certain thing, I will certainly tell you the trick behind that. There is not a single formula in the whole electronics which I ask you to remember without telling any trick. Always I will tell you the trick. Here also there are tricks. There is concept as well. If I am telling you the concept behind that, then also it is fine. Otherwise I will tell you the trick. And that trick you will not forget even after 20 years. Okay. This time constant thing you are not going to forget. Actually this came from the concept only. The time constant should be equal. The speed of charging and speed of discharging both should be equal. That's why this condition came. L by R equals to C by G. So although this is not a comprehensive word, so I'm not going to discuss all these things here, but you are getting this point, right? L by R equals to C by G. Then for lossless transmission line, there will be no loss. That means R should be equals to G, G should be equals to 0. What is the formula of attenuation constant? Alpha equals to under root Rahul Gandhi, RG. Okay. Formula of Z0, under root L by C. Now confusion would be, sir, under root C by L or L by C. So J omega L divided by 1 by J omega C. So under root L by C. Okay. Now phase constant beta. So for phase constant beta, in the initial lecture we wrote down this formula, right? So 2 pi by lambda. So this formula is always true. This formula is also true. 2 pi by lambda is also true. Always it is true. Now lambda could be replaced as Vp by F, right? Lambda could be replaced as Vp by F. So what do we get? What is 2 pi F? Can I write down omega divided by Vp? So this is also another formula of beta. Although you don't need to remember it, so I'm not gonna put it in the box. You just remember this formula, beta equals to 2 pi by lambda. So here it is, beta is depending on omega, Vp, all these things. But I need to make beta dependent on this RLGC. Okay, so that formula is omega under root LC. Omega under root LC. Okay, and what is this propagation constant? Propagation constant is gamma equals to alpha plus j beta. This is your propagation constant, alpha plus j beta. So from this slide, what you need to remember, that for any kind of transmission line, L by R equals to C by G. If lossless is mentioned, that means R equals to G is equals to 0. What is the formula of attenuation constant? Alpha is equals to under root Rahul Gandhi RG. And if R and G are equals to 0, that means alpha is equals to 0. What is the formula of phase constant? That is beta. Beta is 2 pi by lambda. That is always true. But if I want to make it related to LC, then I will write down beta equals to omega under root LC. So this formula I am asking you to remember, beta equals to under root LC. Beta equals to omega under root LC. Then attenuation propagation constant is equals to alpha plus j beta only, and characteristics impedance Z0 equals to under root L by C. So we will apply all these formula and we will see the problems. There is high chances that from these formula only the question can be asked in the examination, and certainly you will be able to solve. So let's solve some PYQs only. Propagation constant gamma is given. You need to find out the value of RLGC, and omega value is also given. Characteristic impedance Z0 is also given. So let's see one thing. Alpha value is given, that is 2, right? And beta value is given, that is 5. Z0 is given, that is 50. So in the examination you will write down whatever that is given, and omega is given, that is 10 to the power 6 radian per sec. Okay. Let's see one thing. Alpha equals to under root Rg, right? And Z0 equals to under root L by C. A very interesting formula I'm gonna get from here. If I do, what I can do here is that, what do I know? That sir, my L by R should be equals to C by G. Say yes or no, right? So can I replace my G? G can be replaced as RC by L. G can be replaced as RC by L. So R under root C by L. Alpha is equals to R into under root C by L, right? So what I am getting? Alpha equals to R into under root C by L. Alpha equals to R by Z0 can I write down? Because 1 by Z0 would be under root C by L. So can I write down R divided by Z0? So what I am getting? Alpha into Z0 is equals to R. Like 2-3 times question has been asked on this formula only. Alpha into Z0 equals to R. They will give the value of alpha, they will give the value of Z0, they will ask the value of R. So what will be the value of R? Here this is meter inverse actually. This is radian per meter. Although you don't need to remember all these units, and Z0 is 50 ohm. So if I need to find the value of R, that would be alpha into Z0. You don't need to remember it. You just need to remember these formula. You just need to remember one thing, that there is a relation between alpha and Z0 to get the value of R. This relation, this is the only thing you need to remember. In the examination, you might get confused, sir, alpha into R is equals to Z0, or sir, R into Z0 is equals to alpha. These kind of confusion can come into examination. So forget about this final expression. If you are not able to remember this expression, then also it is fine. In the examination, we can derive it. But what we need to remember, we need to remember this formula. Okay, just write it down in your rough notebook. Only once you will be able to remember it. And there is very high chance the question can come from this particular topic. That's why I am dealing this topic here. So alpha R equals to alpha into Z0. So alpha is 2 into Z0. So what will be the answer? 100 ohm? No, 100 ohm per meter. Okay, that will be the answer. 100 ohm per meter. So that is the value of R. Okay, I will add a page and take a break. You can then find the value of LGC. These are very easy. LGC value also you can find. Okay. Okay, yeah, so let's get started. What we need to find now, R we have already found out, that is 100 ohm per meter. We need to find out the value of, let's see what all things are given. Z0 is equals to given under root L by C. Okay, and beta would be equals to omega under root LC. So what I can see here is that if I multiply beta into Z0, what do I get? Omega into, basically beta into Z0 I am doing, right? Under root L by C. This and this is getting cancelled. Omega into L. Certainly you are not going to remember all these things, right? Beta into Z0 is equals to omega into L. So what we are getting? L is equals to beta. Value of beta is 5 into Z naught. Z naught is 50 divided by omega, that is under root 6. So what we are getting? 250 microhenry. So that is the value of L, right? Now can I find the value of C? Yes, from here I can find the value of C. So 50 square divided by 250 micro divided by C. So what I am getting? 250 micro divided by 2500. So I am doing the correct calculation, right? Beta 50, 50, 250, 250 micro, 250 micro Henry it is. Okay, so it is coming out to be 100 nanofarad, right? Because this will be 10 to the power 6 and this is your 10. 10 microfarad it is coming out to be. Wait a second, what I am doing? This is 10 to the power minus 6. 10 to the power minus 6. 250 get cancelled, it will be 10. So 10 to the power minus 7, that means 100 nanofarad per meter. Here also there is an error, per meter. So C is 100 nanofarad per meter. Okay. What I need to find? Alpha equals to Rahul Gandhi under root Rg. So alpha square would be equals to, alpha square by R would be equals to G. So G is equals to alpha square, that is 4 divided by R. R is 100, right? So that would be 40 millisiemens per meter, right? So that's the next answer. What else I can see? That whether L by R is equals to C by G, is that condition being satisfied or not? What is the value of L? 250 micro divided by R, that is 100 ohm, is equals to C 100 nano. 100 nano means 10 to the power minus 7 divided by G, that is 4 into 10 to the power minus 3. So this is actually 10 to the power minus 6 and this 0 get cancelled. So this become 25 into 10 to the power minus 7. This is actually 25 into 10 to the power minus 7. What I am doing, I am just simplifying it, and I am just checking whether I am getting the correct answer or not. It was 250 because I know that this condition should be satisfied. So 250 micro divided by R. What is the value of R? R is 100 ohm, right? 100 ohm. So if I solve it, I guess 2.5, what I get? 2.5 into 10 to the power minus 6. 2.5 into 10 to the power minus 6. Do I get the same thing here? 10 to the power minus 4. So 100 by 4. 25 into 10 to the power minus 6. I am somewhere messing it up. In the calculation, there is some error from my side. So I need to see that error. What is the error there from my side in the calculation? Yeah, it was a dumb mistake actually. This was 10 to the power minus 2, no? So yeah, that would be satisfied. Basically, this condition is also being satisfied. L by R equals to G by C. The error I was doing here, it was 4 into 10 to the power minus 2, not 4 into 10 to the power minus 3. So if you solve this condition will also be satisfied. Okay. So just I wanted to tell that there are n number of ways of finding it out. So this will be the maximum question. From this question only you are able to see that all kind of parameters you are able to find. Or it might happen that RLDC value are given, they could have asked you to find the value of alpha beta. So conclusion is this slide only. Okay, let's see one more. This value is given. Attenuation constant alpha they are asking. Alpha they are asking. So let's just say you don't remember any formula. So what you are going to do? So alpha formula is equals to under root Rg. So this I need. Alpha equals to under root Rahul Gandhi I remember. Z naught equals to under root L by C I remember. And one more thing I remember, that is, sir, L by R is equals to C by G. Time constant equated. So from this equation, what I will get? Alpha into Z naught equals to R. So from there, my value of alpha would come out to be R by Z naught. So 0.05 divided by Z naught, that is 50. Okay. 5 into 10 to the power minus 2. 5 into 10, that would be 10 to the power minus 3 per meter. Right. 5 into 10 to the power minus 2 divided by 5 into 10. Yeah. Okay, then 5 into 10 power minus 2 divided by 5 into 10. Okay, 10 to the power minus 3 per meter. So that would be the answer, right? So from this complete lecture, what is the conclusion? The conclusion is, first conclusion is RLGC, RLGC. R and L both are associated with the conductor, and these are associated with the medium that is there. G is coming because of the loss in medium. Conductor is there, in between there is a medium, that's why C is coming. G is coming. Delta Z I need to write. Delta Z I need to write. R into delta Z, L into delta Z. That means in unit length, one R should be there, one L should be there, one G should be there, one C should be there. Then for any transmission line, L by R should be equals to C by G, time constant equated. Okay. For lossless, what will be the condition? R equals to G would be equals to alpha. This is only for lossless. Then there is something called attenuation constant, that is equals to under root Rahul Gandhi. There is something called phase constant, that is equals to omega under root LC. There is something called Z naught intrinsic impedance, that is equals to under root L by C. And there is something called propagation constant, that is equals to alpha plus J beta. That's it. This is the complete conclusion that we have studied in this particular chapter. And it might happen that one question can be coming from here. So this is the conclusion of the complete 50-minute discussion. Okay. So that's it from my side in transmission line. Within like first lecture was of roughly around 1 hour, second was of 2 hour 30 minutes, and this also you would be able to complete within 40 minutes, I guess. So I guess in 4.5 hours you can come, or 5 hours, let's take the maximum one. 5 hours. In 5 hours you can complete this much part for sure. Whatever that I have taught you till now, in 5 hours these 3 lectures you can complete, and certainly there is very high chance that question will be framed from this particular topic in the final examination. And without even any prior knowledge of EMFT, you are able to understand all these points. And certainly, believe me guys, you will be able to solve the problems. In the standing wave pattern, that with the way we have studied standing wave pattern, even if those guys who have studied the comprehensive course in 150 hours or 200 hours as well, they might not be able to solve the problem, because the standing wave pattern we have seen in one circle only. The complete transmission line is coming on just one circle, and if we are able to analyze this circle, then all the questions we can answer. Okay. So I hope you enjoyed this video on transmission line. Although we have covered the comprehensive course, so if you are someone who is looking for GATE 126, who will be coming back for GATE 126 examination, then EMFT course has been uploaded on YouTube itself. You can go and check that course out. Okay. EMFT course is on YouTube itself. But yeah, so you can cover it comprehensively if you are someone for GATE 126. But some guys were saying for GATE 125, they were saying that, sir, waveguide revision. Look, the thing here is, in waveguide, I cannot break down the topic like transmission line. Look, waveguide is waveguide only. Like there are n number of formulas. There are a lot of formula in the waveguide, right? So I cannot I cannot tell that, sir, even if you haven't studied it right from the beginning, still you can study it, because there will be a lot of formula like that. And if there are a lot of formulas, so I cannot expect aspirant to remember those formula. But if you want to revise it, then just go and watch these lectures quick. You can watch this lecture very quickly. These lectures are over roughly around 10 hours. But within 2 hours you can complete it. Like introduction to a waveguide. So there I will be telling you that how a waveguide is propagating in a rectangular box. So that thing I will tell you there. So within 10 minutes you will be able to watch this video. You will be able to revise as well. And certainly I can tell you, in these videos only you will get at least 10 to 12 new and very interesting thing. And that will make your subject very interesting. I can guarantee this thing from wherever you have studied. So for the revision, you can study the comprehensive lecture as well. You just need to skip that part which you already know. Okay. So in waveguide, I did not think of bringing any different video. Why is that so? Because from here only you can cover the whole part, no? Right? And you were asking about oblique incidence. So in oblique incidence only you can watch all these videos. Here I have given the proper assumption, that which assumption you need to take into action, why we take that much assumption into action, and how do we develop that formula, why do we develop that formula. So here you will not find any needless derivation like beta cos theta t, those beta cos theta I, then I write down the formula in a very complex way. This thing is not there. You have seen our lectures. In our lectures, the more important part is how do we understand it in a practical way. It's not that practical that we are making our food using all these things using all these concepts. We are not making our food. We are just understanding it in a visualization, that how it would be looking like. Right? Are you getting this point? So in oblique incidence as well, I have given enough visualization that you would be able to see the wave, how the wave is coming, where the electric field is dancing, where the magnetic field is dancing, and why there is a certain formula for that. So certainly you can go and check out these videos. And if you just want to revise it in a very quick manner, then I solved this PYQ of GATE 2013. Okay. So this is a 30-minute video. Here I have given the concept as well. So you can watch this video as well. Here, this particular PYQ has been solved, a lot of times this is not solved correctly. So that PYQ also I have solved. So you can watch this video as well. So if you watch just these videos, then your oblique incidence will be completely revised, and it will not take more than 2 hours. Within one day you can revise from here as well. Within one day you can revise from here as well. It will not take more than 2 hours if you have already studied the topic. You just need to see what all new things I am teaching and how I am making it interesting. Certainly you will find it interesting. If you feel like that, sir, my oblique incidence is, I do not find interest at all, I do not even understand it, just watch these videos comprehensively. You will be able to understand, believe me. Okay. And a lot of new things, a lot of assumption that we take while deriving the formula, those I have also written down. And you will never feel like that, sir, why we are going into derivation, nothing like that. We are not going into needless derivation. Wherever it is required, there we are going. Okay. And for antenna part, you can refer these lectures. Antenna is also uploaded there. So for antenna part as well, you can refer these lectures. At least in antenna, you cover these two, antenna parameters and Friis equation. These two are very, very important. From these two videos, questions can be asked. But if you have studied antenna from here, then only you can cover. Like if you know what is Hertzian dipole antenna, if you know what is linear dipole antenna, then you can cover these two videos. Okay. So from antenna, you can cover this part. Is that okay for you? So I'm not gonna bring more videos on EMFT. Okay. I'm not gonna bring more videos on EMFT only for your GATE 2025 examination. For GATE 2026, we will bring more videos, but for 2025, those who never studied EMFT, they don't need to study all these things, antenna and all these things. This was only for those guys who are asking for revision. Okay. But those who never studied EMFT, they can cover this much part of transmission line that I have taught just now. This much part you can cover. After this is of no use for you. This thing of no use for you. This is of no use for you. Those guys who are studying it for the first time. Those who have already studied it, they want revision, then they can watch these videos. Okay. And yeah, one more error I did in the previous video. There was this error from my side in the previous video. There I wrote down this thing, that Pin will be the power incident, this will be the power reflected, and this will be the power transmitted. So formula for power reflected will be mod of gamma square into Pi, and formula for power transmitted would be 1 minus mod of gamma square into Pi. Okay, it was written opposite. So basically this will be your power transmitted and this will be your power reflected. So here what do I need to find? Here I am finding power transmitted. So this is the power transmitted. Power transmitted is equals to this thing. So what will be the power reflected? That will be 0.25 into Pi. Basically for power reflected, I just need to take the mod of gamma square. So mod of gamma is 0.5. So my power reflected would be mod of 0.5 square into Pi. So that would be 0.25 into Pi. So that was an error that I did in the previous video. So that I am rectifying now. Okay. So yeah, that's it from my side for GATE 2025. Now, I don't think there is any other need of bringing more videos for GATE 2025 now. Now, whatever that you have studied, just revise that and have full confidence on yourself and do well in the examination. And for GATE 2026, if you are someone targeting for GATE 2026, then first thing is that why you are watching this video if you are targeting for GATE 2026. But if you feel like that I will write down the GATE 2026 examination in a good manner, then you can come and get our course. Here, you can apply the code TITANS15. So we are giving 15% off on all the subject-wise courses, full courses as well. So whatever the subject-wise courses you want to purchase, that you can purchase, or if you want to purchase the full courses as well, then you can purchase the full courses as well. You will get 15% off. You need to apply the code TITANS15. Okay, and there you will find who is teaching all the subjects. So I can tell that in EC, apart from control systems and mathematics, all the subjects will be taught by me. In EC, apart from control and mathematics, all the subjects will be taught by me. And in electrical core will be taught by Anish sir, and control system and mathematics will also be taught by Anish sir. Rest all subjects will be on me. Okay. Yeah. Thank you very much. I hope you enjoyed learning EMFT from me. You can comment down if you enjoyed it. Yeah. Thank you very much.